So in this video we're going to go through page 78, it's sheet number 7 as Conics sections question 1. So reading the question, the directrix of the axis of an ellipse are given, the focus is also shown, the eccentricity of the conic is 0.8. We're asked to construct the ellipse and make notes on the construction of the ellipse in the space provided below the drawing. So just to kind of recap on yesterday, I know there's a lot of theory and there's a lot of new information and it's probably quite hard to understand online, but when we're drawing it will make more sense. So first of all, what we need to take from that question is the conic is 0.8, and from yesterday, any conic that has an eccentricity of less than 1 will be an ellipse. So your ellipse eccentricity will always be less than 1. A parabola will always be 1, and hyperbola will always be greater than 1. So that's just something you can know. If we go down to our workings here, so the formula that we needed to know yesterday was the eccentricity, which we'll see what that is in a second, is the point from the focus over the point to the directrix. And we're told, we're given the answer to that already, we're told that's 0.8. So if we convert 0.8 into a fraction, that's the same as 8 tenths. So that's like saying the distance from the point to the focus is 8 and the distance from the point to the directrix is 10. And that will result in an eccentricity of 0.8. If we were just to multiply that up, because if we're working off 8 and 10, our measurements are going to be quite small. So we're going to multiply that by 5 just so that we can have a bigger measurement to work off of. So I multiply 8 by 5. Let's go right in 5 there. You can multiply that whatever you like. That could be 10, it could be whatever you like. But just, you want to increase the size so that it's easier to draw. Multiply by 5, 8 by 5 is 40, 10 by 5 is 50. So that measurement is what we're going to use for the moment. So 40 is your distance from the point to the focus, and 50 is your point to the directrix. So I'm going to start off and start drawing then. I'm going to just draw a line up 40 for the moment. And I'm going to draw a light line across. And then I'm going to draw a line out 50, because it's 50 from the directrix. Where they cross, so I came up 40, out 50, where they cross will be a point on your eccentricity line. I'm just going to draw it in blue so you can heavy it in. So I'll label that, that is your eccentricity. That is your eccentricity line. So next what we're going to do is we need to find, and this is going back to our page that we've done before. So we have a directrix, we have a focus, we need a vertex, and also we need to find an ellipse has 2 vertex. So we need to find a vertex over here and a focus over here. So a rule at all conics is if you draw a line, I'll do a different color. If you draw a line from the focus back to the eccentricity at 45 degrees and drop it straight down, that will find your vertex. That's just a rule you need to know. So that angle there is 45 degrees. That's the same for every conic, even the parabola, hyperbola. If you go back at 45 degrees, drop a line down, that will find your vertex. We can do the same thing on the other side. So if I draw a line at 45 degrees, I might need to extend it out a little bit. If I draw a line at 45 degrees, to hit your eccentricity, drop it down. That is then your vertex there. So that's your second vertex. That's your vertex 1. If I draw a line, let's use a different color again. I'm going to draw a line straight through the focus. That is your latus rectum. So, that's just going back to the terminology that we have done over the last few days. We have our latus rectum, we have our vertex now, we have our focus, and we have our vertex over here. So how do we find points along that? What we need to do is we need to draw ordinates. And, sorry, my camera's moved. So we need to draw ordinates along this line. So what we can do is anywhere, actually what we'll do is measure it out for the moment. But these ordinates can be anywhere. So I'm just going to do every 15, 30, 45, 60, 75, I'll say 90 there for a second. How we find those points? We're going to draw a line up to hit the eccentricity line, up to hit the ECC line. You bring it back to hit the latus rectum. Then you get your compass. Your focus is your center. That becomes your radius, that distance there up to where it hits. And we rotate it down to hit our line. And then that becomes a point. So we'll do the next one. Draw a line up to hit the ECC. Back to hit the latus rectum. Your focus is your center. Take that radius, swing it down. That will now be a point on the curve. Keep going. So start to speed up now that you have the actual method. Up to hit the ECC. Back to the latus rectum. Your focus is your center. Take that distance, swing it down, and that's a point. Quickly do the rest. If you want to do 2 or 3 at a time, you can. Up to hit the ECC. back to your latus rectum. And then you rotate those down. Go to there. So now each of those are points on, extend that down further. Each of those are points on your curve. There. Okay, now also, so you know where vertex is a point. Where the latus rectum and the ECC meet will always be a point on your curve. That will always be a point. So we have our points all the way along. Now we can just lightly draw the curve. And then once you're satisfied, you can go heavy in. So maybe curve or something like that. So that's the first half. How do we get the bottom half? We could do the same thing again, but there's no need. So what we just do is we're going to extend these down. And then you're just using your compass. Take your distance, step it off. Lightly join this again. Now we need to focus on the quality of our curves. Some of the assignments uploaded during the week, your curves are very poor, so focus on the quality of the curves. So lightly join the dots, and then once you have a kind of a trail to follow, then you can heavy it in one continuous line. So that is something like our curve should be. Okay, so question 2 now. I'm not going to do this, but we're just going to get you started. So it is the very same process. Make sure you can see. It's the very same process. So this time the question ECC is 0.75. So we can start, you can write your formula in the calculations area. ECC equals PF over PD. So we're told that that is 0.75. So 0.75 is the same as 3 over 4 because it's 3/4. So what we can do then, we could multiply that by, let's say 10. So that equals 30 over 40. So then that is the distances you use. So you would come up 30 from the point to the focus. So come up 30 here. Then 40 from your directrix, so your point to your directrix. Then use the very same process to complete the question.